1967. In that year, a researcher, during an experiment that was supposed to fail, stumbled upon a discovery that challenges our view of cellular energy today. What does the simple red light from a weak lamp have to do with the fundamental power inside every single one of our cells?
That's the start of a truly fascinating and unplanned chain of events. The Hungarian physician Endre Mester originally wanted to prove that lasers could cause cancer. For this, he used an extremely low-power ruby laser. It was too weak for the tumors. But he noticed something unexpected on the shaved areas of the test subjects. The fur grew back significantly faster, and small wounds healed better. He had, without realizing it, discovered the foundations of photobiomodulation, the targeted influence of biology through light.
And today, decades later, this idea is suddenly everywhere. Red light panels for home use, masks, devices for athletes. It promises everything from smoother skin to faster muscle recovery. And the first, honest reaction is often disbelief. How can mere light do all that? It just sounds too good to be true.
That skepticism is the logical first step, because it contradicts our everyday experience with light. We associate light with warmth or vision. The idea that it can send a targeted signal to our cellular machinery is foreign. But research shows exactly that. It's not about heat, but about pure information in the form of photons. Our body is designed to respond to very specific wavelengths, much like a plant relies on sunlight for photosynthesis.
Okay, so the light hits the body, but the crucial point is how it's supposed to communicate with the mitochondria, those tiny power plants in our cells. They don't have eyes or antennas.
No eyes, but they do have highly specialized receptors. The absolute centerpiece of this process is an enzyme called cytochrome C oxidase. You don't need to remember the name, but you can think of it as the central control module in the mitochondrial respiratory chain, the very place where energy is actually produced.
A control module that responds to light. That's an amazing concept right there.
Exactly. And this module is biochemically engineered to have a kind of favorite color. It specifically absorbs light in the red and near-infrared spectrum, wavelengths between roughly 630 and 850 nanometers. When light of this wavelength hits the enzyme, something crucial happens.
And what would that be?
Normally, this enzyme is slightly inhibited by a small molecule, nitric oxide, or NO for short. You can picture it as a handbrake that's lightly pulled in an engine. It doesn't stop the engine, but it makes it inefficient. The energy from a red light photon is just enough to essentially push this braking NO molecule off of its binding site. The handbrake is suddenly released.
So the light isn't a battery charger at all. It's more like a mechanic who frees up a stuck part in the engine so it can run smoothly again. It's an optimization, not an external energy supply.
That's a perfect summary. As soon as the brake is released, oxygen can bind much more efficiently. The entire electron transport chain speeds up, and the result is a significantly increased production of ATP, our body's universal energy currency. The cell suddenly has more fuel for all its tasks, whether it's repair, communication, or defense.
But more engine power usually means more exhaust fumes. If our cellular power plants are running at full throttle, don't they also produce more oxidative stress, more cellular waste that make us age?
That's the logical thought, but this is where the elegance of the system reveals itself. The opposite is true for two reasons. First, a more efficient engine produces fewer harmful byproducts. Less oxygen is leaked and turned into reactive oxygen species, or free radicals. The process runs cleaner.
Okay, so less waste through efficiency. And the second reason?
The second reason is an active protective response. The light signal activates a master switch for the cellular defense system, a transcription factor called NRF2. When this switch is flipped, the cell ramps up production of its most potent homegrown antioxidants. So the cell not only becomes more powerful, but it also upgrades its internal protective shield at the same time.
That explains the effect at the cellular level, but let's get practical. All of this sounds plausible for the skin, which is easy to reach. But what about my aching knee after a run or a tense shoulder? The problem is deep in the tissue. How is a lamp supposed to get there?
This is where the distinction in wavelengths is crucial. The visible red light, around 660 nanometers, doesn't actually penetrate very deeply, maybe a few millimeters. It's ideal for anything related to the skin: collagen production, wound healing, superficial inflammation.
And for depth, you need the invisible light.
That's precisely where near-infrared light, or NIR, around the 850 nanometer range comes in. This wavelength has the special property of being minimally absorbed or scattered by water and hemoglobin in the blood. This allows it to penetrate much deeper into the tissue, several centimeters. It can reach muscles, joints, tendons, and even organs to initiate the exact same cellular mechanism there.
So if I'm breaking it down, a specific light wave acts like a key. It unlocks the engine of our cells so it can run more powerfully and cleanly. The effect isn't magic, but simply the result of the cell suddenly having the energy and resources to do what it's designed to do: repair, protect, and function.
That is the core of it. It's an impulse for self-optimization, built on the most fundamental processes of our biology. And it shows us that sometimes the simplest external stimuli, like a specific color of light, can trigger the most profound internal responses.
And that's our thought for today. We hope these insights have provided a bit of enlightenment, pun intended, and maybe sparked your curiosity. Thank you so much for spending your time with us. Stay healthy, stay curious, and, as always, we wish you a long and happy life.
Until next time.